Hello and welcome to the module on functions. This specific video is on functions and relations, and it's an introduction. There's going to be some vocabulary. Hopefully you have already printed out the worksheet that goes along with this video. If you haven't, please stop the video and go ahead and do that. You can follow along on that worksheet and fill it in as we go, and that way you can use that as your notes to complete the rest of the assignments. So if you look at the top of the worksheet that you printed out, you'll see there's a few spots for some vocabulary definitions. So you can copy these down now, and as you do that, I'll go ahead and I will explain them. So we start with a relation. So a relation is a set of ordered pairs. And here we have an example of an ordered pair, just in the form x comma y, but it could be anything. It could be 2 comma 1, negative 3 comma 4. So any set of ordered pairs, so a group of ordered pairs. The domain is the x value in those ordered pairs. Another word for domain is input. So if you look at this first ordered pair that I wrote, 2 comma 1, the x value would be 2. So that would be the domain or the input. Then we get down to range. The range is the y value in an ordered pair. We can also call it the output. So again, going back to this ordered pair I wrote 2 comma 1, the range or output would be 1. Next we get to function. This is the more difficult one of the 4 that we're going to talk about. This is a set of ordered pairs where each domain value is paired with exactly one range value. So we're talking about a relation because it's a set of ordered pairs, but it's a specific relation. So every set of ordered pairs is a relation, but only some of them are actually functions. So I think the best way to understand this, where each domain value is paired with exactly one range value, is just to do some examples. So we want to scroll down on your paper, and we have some examples here for us. Right here in this first box, we're going to look at this first. So we have right here our relation, our set of ordered pairs. There are 4 of them in this case. You could have less, you could have more, but we're going to work with 4 to start. So the first thing I want to do is I want to list the domain values here. We're going to actually create what's called a mapping diagram. So I'm going to start with the domain values, and as we talked about, the domain values are the x values. Right, so those are our x values. So I'm going to list them 1, 2, 3, and 4. Now I'm going to do the range values, and from our definitions we know that means the y values. So I have 4, 5, 6, and 7. Now I'm going to do what we call mapping. So I follow what the ordered pair tells me. So 1 maps to 4, so I'm going to line those up. 2 maps to 5, 3 maps to 6, and 4 maps to 7. So I just map them the way the ordered pairs told me to map them. So now, is this a relation, is the question I have here. The answer to this is yes. It's always yes, because remember that any set of ordered pairs is a relation. And here I have a set of 4 ordered pairs, so they are definitely a relation. But is this a function? Well, let's see about our test. We talked about that each domain value is paired with exactly one range value. So 1 maps to 4 and only 4. 2 maps to 5 and only 5. 3 maps to 6 and only 6. And 4 maps to 7 and only 7. Therefore, this is a function because it does meet the test. We'll try a few, and then when it doesn't pass the test, I think it'll make a little more sense as well. Let's try this next box over here. Actually, you know what? Let's go down, scroll down. Let's do this one right here. All right, so I'm going to look at my domain values. Again, those are my X values. So I'm going to write those in, 0. And then here I have 1. Now here I have a 1 again, so I'm not going to write it twice. Next I have a 2. Now I'm going to go to my range values. Remember, those are the Y values. So I have a 1, a 3, a 5, and a 7. Now I'm ready to map. So I'm going to follow each of the ordered pairs. 0 maps to 1. 1 maps to 3. 1 maps to 5. And 2 maps to 7. All right. So now I'm going to answer my questions. Is this a relation? Yes, it is a relation, because it's just a set of ordered pairs, and every set of ordered pairs is a relation. Now, is it a function? Well, let's see. Does every domain value map to one and only one range value? 0 maps to 1 and only 1, that works. But 1 maps to 3, and 1 maps to 5. So because of this spot right here, it's not a function. So that makes it not a function. So if you compare the two and you look up here, you can see that in my domain, each of these numbers has one and only one line leading away from it. That created a function. But you can see here how I have something that looks a little bit different. When you look at the 1, there are 2 lines leading away from the 1. That created an instance where it was not a function. There are 2 more examples on this page, so I'd like you to see if you can fill them in, and then we'll look at them together. So please hit pause on the video and try to do the other 2 boxes on this page. All right, we have the 2 boxes completed now, and you can check your work and see. I did the mapping diagram here, and I just want to call your attention to one thing. There were 2 3s in my range value, but I only wrote it 1 time. So you can see how this mapping diagram worked out. This is a relation. Again, they're all going to be relations. And this is a function. So this one might be tricky only because we do have this instance over here, but that's with the range. And I don't care about the range. It's the domain that it's in charge. It's the domain that makes the difference. So I'm only looking to see if each of my domain values has one and only one line leading away from it, and it does. Therefore, this is a function because I am only looking at the domain. That's all I care about. I don't care if they all map to 3 in this case. It would still be a function. Now we go down and look at this one. And again, there is one thing here. Even though the range values were given out of numerical order, so it went 1, 3, 2, 4, I did write them in numerical order, 1, 2, 3, 4, and that's the